So when we say algebra, it consists of two different quantities. One is variable, another one is constant. Whereas variable varies across time, person to person it may vary. Constant means it remains same. So using this, we are going to express something. How we will express? Like your lucky number plus 5 chocolates. I told you. So it varies person to person, but that has to be expressed in a certain way. How we can express? See, by that time, these variables will help us. So x is your lucky number plus 5 is the constant that I am adding. So we will express in this way. So these kind of expressing things, like 2 more than 5 times your lucky number, like I say, means how that can be mentioned? 2 more than 5 times your lucky number. This like we can represent this. So this way of representing or expressing things is called as algebraic expression. What is this? In this expression, see, we call it a term. It is a combination of variable and constant. So here we have two terms. Also, we classify this based on number of terms. We classify this based on how many number of terms it has. So in that way, if it contains only one term, if the algebraic expression contains only one term, we call it as monomial. How do we call it? Answer, man. Monomials. So it has only one term means we call it as monomial. If it has two terms, then we call it as binomial. If it has three terms, we call it as trinomial. If it has four terms, simply we call it as polynomial. More general way, multinomial. The definition of polynomial or multinomial is an algebraic expression containing one or more terms is called as polynomial. So these all are polynomials, but when it is 1, 2, 3, we have specific names. More than 3, we call it as a polynomial. That is it. Okay. But in deep through, it has some certain meanings. These two are not same, but as per the basics, this is enough. So now we speak of terms. Here, like terms and unlike terms. So the like terms are nothing but if two terms are having same variable part, whatever it is, the power, everything should be same. So that type of terms are called as like terms. So when I say 2x square y, root 2x square y, you see, though the number is different, here x square y, here x square y, both are like terms. Like 7a square b, 9ab square, both are like terms or not? No, they are not like terms. See, a power 2, here a power 1, they are not like terms. So when these are not like terms, we call it as unlike terms. How do we call it? Okay. So if it has same literals, same alphabets within the same power, we call it as like terms. If it is not having, then it is unlike terms. So using this, we are going to define the fundamental operations. Are you observing the pattern that whenever we define new things, immediately we define the fundamental operations? Is it or not? We define number system, the operations on the numbers. We define fractions, then operations on fractions. We define rational numbers, operations on rational numbers. That is how it goes. Now we define algebraic expression. Now the operations on this algebraic expression. Shall I erase this? Have you noted down? Okay. So the very first operation is addition or subtraction. So addition or subtraction requires only like terms. So if it is like terms only, we can add or subtract things. Okay, so the first and foremost condition, the terms that we are adding should be like terms. If it is not like terms, if those are not like terms, then we can't add those. We'll keep as it is. For example, take this example, 2x plus 3y plus 7x square y plus 3x y square. This like one expression is there. Now I am going to add this with x square plus 3y square plus 2yx square and plus 7x y square x. Okay. Yeah, okay. Am I audible? Am I audible? Okay, good. See, here we are adding two algebraic expressions. Only the like terms can be added. List out the like terms. You see, here x square is there, no more x square there. So here x square. We can't add because the same picture has to be there, like as a picture. Now you see, here y square is there, here y is there. We can't add. Here x square y, here y x square. Both are same or not same? Both are same. X power 2 y. Here also x power 2 y. Though the order is front and back, both are like terms. So these two can be added. And these two same. Order only different. Okay. So only these two can be added. Now how we can add the remaining things? We can't add. We should keep it as it is. Better if we write from powers bigger one to the lower one. Okay. So x square plus 3y square and then power 1. We have 2x plus 3y and you see this 7x square y, this is 2x square y. It works like this. 7 apples plus 2 apples. How will you say? We have 9 apples, like you say, right? The same way, 9 apples. Here this is the apple thing. Whatever it is, that same way you should pronounce. 7x square y plus 2x square y. Then we have 9x square y. The same way, these two can be added. 7xy square plus 3xy square plus 7xy square. Then that is 10xy square. That is how we should add two algebraic expressions. Any doubts in this? Do you have any doubts? I'll give you one simple example. Try to work it out. Subtraction also in the same manner. But here we need to change the sign of the which we are subtracting. For that we need to change of sign. Okay. Now take this example. 15x minus 13x minus x plus 8x. What is your answer? How this can be added or subtracted? And the next one, 9d plus 17 plus 5d minus 22. How we can add this? You see, we have all the terms are like terms. So 15x minus 13x, how many? Same thing, 15 apples minus 13 apples. We have 2 apples, that is 2x. So 2x minus x. Two x minus x. Two apples minus apple. That means 1 apple. 1 apple. So 1x. Now that 1x plus 8x, you have 9x as your answer. You see, 15x minus 13x, that is 2x minus x plus 8x. Then 2x minus x is how much? It's like 2 apples minus 1 apple. Then we'll have 1 apple. That means then simply x plus 8x. So 9x will be our answer. Same way here, is everything can be added? No. What is the first and foremost condition? The terms should be like terms. Here list out the like terms. Which are all like terms? Which is like term of 9D? See, 9D, this is not 17D, it's only 17. Okay. Okay, then 9D plus 5D. In total we have 14D. Then 17 minus 22, it is -5. Yes, good. That is it. Now 2 more questions, then we'll move on to the multiplication and division. Eight x square plus 8x minus 3x square plus 12x. Eight m square y square minus 3 m square y square minus 12 y square m square. Mn minus 6mn plus 6mn minus 3mn minus of minus 2mn. Seven AB plus 7BA plus 2B. Yes. Simply work out these 4 questions and answer it, then we'll move on to the multiplication and division. You also work out these questions and tell the answers in the comments. I'll see you in the tomorrow session. Thank you.